Hey, everybody, and welcome back to another Adventures in Machine Learning. I'm your host, Charles Max Wood, and this week I'm talking to Derrick. Now, Derrick, you're a data scientist at, I just had it in front of me, at Layer. It says marketing at Layer. So are you a marketer, or a data scientist, or a data scientist marketer?
Well, that's an interesting one. I am doing marketing, but using data science or on the data science side. So maybe to go back a little, Layer is an MLOps company. And so I create content that is data science and machine learning for developers, obviously in a way to market the MLOps company as well as to assist developers in their day-to-day work.
Very cool.
Did you work your tail off to get that senior developer gig just to realize that senior dev doesn't actually mean dream job? I've been there too. My first senior developer job was at a place where all of our triumphs were the bosses and all the failures were ours. The second one was a great place to continue to learn and grow, only for it to go under due to poor management. And now I get job offers from great places to work all the time. Not only that, but the last job interview I actually sat in was a discussion about how much my podcast had helped the people interviewing me. If you're looking for a way to get into your dream job, then join our Dev Heroes Accelerator. Not only will we help you get the kind of exposure that makes you attractive to your dream employer, but you'll be able to ask them for top dollar as well. Check it out at devheroesaccelerator.com.
Now I want to talk about that, but we'll talk about extensions for TensorFlow, and then maybe we'll have you come back and talk about machine learning and data science for marketing, because, I'm just thinking through all the implications of what you just said. It sounds really cool. But you wrote this article on KD nuggets. What does KD stand for, by the way?
I'm actually not very sure. I think it's knowledge nuggets. I'm not entirely sure.
Okay. It's all good. I thought you might be more involved with the website than.
And no, it's a very popular data science blog, and so many people publish the articles there. And so this is an article that I republished on their platform.
Okay, gotcha. So but you basically gave us, you called it the best machine learning frameworks and extensions for TensorFlow. And it's always interesting, right, to kind of get into what people are using, right? See this in other arenas, right, where people are going, what stack did you use to build it, right? Or even within machine learning, it's, what algorithms did you use, or what frameworks did you use, or things like that. And so, this will be really fun to just dive in and kind of go, okay, what are the things that you think are the best frameworks or extensions that you think people ought to know about? And I don't know that you're necessarily saying these are the ones that you have to be using, but these are things that people probably ought to know about, correct?
Correct.
Now, so how did you decide what went on the list, right? Because there's a ton of stuff out there.
The way I chose this is based on the ones that I use, and also based on their popularity. And we can check the popularity based on GitHub stars, and the amount of content that is available out there.
Yeah, that makes sense. So not all of these are things that you use then? Some of them are based on the GitHub stars, or was it based on both?
Both. Most of them are the ones that I've used. Some of them I haven't actually used them in a real project, but they're important to mention in case someone is looking for something like that.
All right. So let's go ahead and just kind of go down the list here for a minute, and you can kind of explain what some of these are. The first one is TensorFlow Hub. And as much as I've kind of been dabbling in this, I didn't know that this was a thing. So do you want to kind of run us through what this is?
So this is, if you've used mobile applications, say you already know of, say, Play Store or iOS Store. Mm-hmm. So this is like a store for machine learning models. So this is a place you can find various machine learning models that are already trained, and you can start using them right away to solve your problems. For example, there are numerous models already there for natural language processing, image classification, sound classification, and so on. So instead of spending all the time building your own models, you can just go there and try a couple of models and see if they solve your problem.
Yeah, that makes sense. No need to reinvent the wheel, right?
Yeah.
So what kinds of models do they have?
So, for example, there's a model I've actually used. There's one I used for classifying whether detect the image of a plant, it was able to classify which type of disease the leaf would be having. So I just went there and I downloaded it. So you can see it saves me a lot of time in terms of I didn't have the data set for starters. So now you can see that has reduced my time significantly. Mm-hmm. So apart from that, there are image classification models, style transfer models. These models have already been trained, and so you just download them and you start, and they're ready to use.
That makes sense. You saying plant disease, it reminds me, I was on a gardening group for Utah, which is where I live. And somebody actually asked what plant was on Facebook, and somebody actually pulled out their phone and pointed it at their screen and used their phone to use, I'm assuming, a machine learning model that had been pre-built and put into an app and said, oh, my phone says it's this. And so, yeah, I'm guessing they probably just use something off of this with maybe a little bit of modification.
Sure, it's possible. Actually, there is something we call transfer learning, where you can use a model that is already trained, and then you fine tune it on your own data set. So you'll obviously spend less computational resources in training the model, unlike if you were to train that model from scratch.
Right. So you use it on broad classes of plants, and then you fine tune it on specific species of plants or something like that.
For example, if you are, let's say, which is a good example, let's say you're trying to classify cats and dogs, and for example, you download the pre-trained ResNet model. So for example, you will be having a few images of cats and dogs, not as many as the ones that were used in training the original model. So you can just use your data that is not as much as the original one to fine-tune the model to make it usable for your own.
That makes sense. Huh. It's really, really interesting. So does it provide data sets as well, or is it just pre-trained models?
That is a separate library known as Tensorflow datasets, and it also contains numerous datasets, which makes it easy for someone to just try out some machine learning projects. For example, there is the MNIST, the one for images. They also have data like a data set for flowers. So using that package, you can also get access to numerous data sets without the need to go and source the data yourself.
I gotcha. So how much work is it to integrate a model from the TensorFlow Hub into your application?
It's actually probably like a couple lines of code. It's quite easy. They also provide a documentation showing you how to integrate each of those models. So it's quite easy.
And does it work with TensorFlow JS or only TensorFlow in Python?
I believe it should work with TensorFlow JS, but I actually have not used TensorFlow JS, so I would not be able to give a 100% sure answer for that.
Okay, that's fair. Anything else we should know about it before we move on to the next tool or framework?
I think that's it for now.
Awesome. Well, the next one in your list is the TensorFlow Model Optimization Toolkit.
Well, this model optimization is very important, especially for if you're doing machine learning models that will run on the edge. That is meaning on, let's say, Arduino boards or on mobile applications. Once you train these models, some of them initially are quite large. So you need to find ways to make them smaller so that they can, for example, fit on a mobile device. And the reason why you would want to deploy that model in a mobile application instead of using, for example, an API is so as to reduce the latency during prediction. Apart from that, if you are deploying a model to a place where the internet connection is, say, poor, then it means the user will wait a long time or will not be able to get predictions since your model relies on an internet connection. And so in times like those, you want to, for example, package the model with your application. And so in order to make sure that that model works and can be able to give inference in a short period of time, what you do is that you ship the model in that mobile application. And so that is where optimization of the model comes in. That is, for example, you can create a TensorFlow model and then convert it to become a TensorFlow Lite model, which can be served in mobile applications, basically.
Well, that's cool. So what's the process for using something like this?
Well, the first thing would be to create your normal Keras or TensorFlow model. Once you create the model, you can use the TensorFlow Lite converter to convert it into a TensorFlow Lite model. And it's quite straightforward. TensorFlow does a good job at providing good documentation for doing this.
Yep, very cool. So you just grab the toolkit, plug it into TensorFlow, and then just follow the directions. It's pretty simple.
Yeah.
Are there any drawbacks to this? Because I'm imagining that a light model might not be as accurate or as precise.
You're actually right on about that. So optimizing these models leads to just a slight decline in the model accuracy. So it's something we can live with so as to make sure the models are available on edge devices such as Arduino boards and the mobile applications. It's not that significant, but it's true there is reduction in the accuracy.
Right. So I guess what I'm kind of driving at is, like on my mobile phone, in certain use cases, it probably doesn't matter a ton. But in other use cases, it may matter, just depending on how much fidelity I need in my model.
Actually, what we usually do is we'll ship the model with a mobile application, but then we'll keep updating it over the air. So, for example, when a new model becomes available, we can trigger the mobile application to download the new model. So, in the event that there's no connection, then you'll use the model on your device. But then whenever there is an internet connection and maybe your phone is idle, we can trigger the new model to be downloaded without interrupting the use of the application by you.
That makes sense. So then you get the high fidelity model if you have a decent connection to the internet, because you can send it off to a machine that can run it through whatever algorithm or neural network you have up in the cloud. But if you can't, then you get a good enough answer from your mobile phone that can run a light version locally.
Yeah, it's like, for example, if you are using one of these ride-hailing apps and you haven't used it for a while, the next time you use it, you might notice that it starts downloading something.
Mm-hmm.
So it means now it's downloading like the new machine learning model.
Right. That makes sense. That's really cool. How about TensorFlow recommenders? What does that do?
I haven't used this one actually that much, but the aim of this one was to make it easy for people to build recommendation systems.
Mm-hmm.
Yeah, so it allows you to prepare your data, you train, evaluate, and then deploy like a recommendation system. For example, recommending, say, movies, food, something like that. It just makes the process of building recommendation systems easier.
Right. People who listen to this podcast also listen to this other podcast.
Something like that.
Yeah, that makes a lot of sense to me. That's one that I definitely want to go play with. I've actually been building a directory of like podcasts, videos, what else, courses, stuff like that. And it'd be really interesting to, as people put in information as far as I rated this course 5 stars, I rated this podcast episode 5 stars, I rated this, whatever. Yeah, then it starts recommending, oh, well, people who like what you like, we think you'd also like this other video or this other podcast episode or this. Yeah, I think that'd be really, really interesting, right? Have you looked at this yet?
Yeah.
Interesting. Yeah, I'm still going down the list. You've got TensorFlow federated. What does that do?
This one is a very interesting one. So, for example, people are super concerned about privacy. Mm-hmm. For example, a good example is when you're using the keyboard on your phone. You should be able to learn the words you use when communicating to people, but at the same time, you would be concerned that, say, if you're using a Google keyboard, that this information, like your text messages, are not being sent to the server. And so this is where this library comes in, because what it does is that a machine learning model is trained on a server somewhere using some proxy data, or maybe we could call it some dummy data, and then it's sent to your mobile phone, to my mobile phone, and to the mobile phone of every other people. And then it will learn and improve by being trained on the data on that phone. Like, the data is not sent to the server. So the server is the provider of this keyboard, does not see your text messages. Your mobile phone is also trained on my mobile phone and someone else's mobile phone. And so now, like, the for example, like, it's like we're creating like an average of these models, and then we are sending the average to the server, which is then sent back to all users without our data being seen by the server. Does it make sense to you?
Yeah, that does make sense. And kind of to restate it a little bit and to give an example. So, how do I put it? So, and I'm going to, at the risk of getting a little bit political, I mean, pretty much every big cloud company has given me reason to worry a little bit about my privacy, right? Amazon, they have the Echo, and I have Echoes all through my house, but I know it's listening to me all the time, right? And I've heard instances where they've actually handed over recordings to law enforcement and other folks without warrants, right? And I want them to go through the process, right? I don't want them to just hand it off. One major case for Apple. Apple was one that I always kind of felt like, oh, they're going to protect my information at all costs, right? I mean, there was a mass shooting in California several years ago, and the shooter's information they wouldn't even hand over, right? But then recently, Rudy Giuliani, who was Donald Trump's lawyer, they just handed that information over. And as far as I can tell, they didn't put up a fight. And that concerns me. I figured Donald Trump and Rudy Giuliani can put up a fight on their own, but it concerns me that they're just handing over data without, whatever. And so if they're collecting data on a device that I use every day, then yeah, I'd rather have it federated with everybody else's data so they don't know it's me, right? And so that they're not spying on me all the time. And so that makes a lot of sense, that I can tell people, there's a system out there that is going to make it hard for them to identify your data from everybody else's data in that way.
In the end, you can see that we still push the machine learning field forward by making sure that we are training models that actually make our lives easier, but we are also protecting the privacy of our users.
Yeah, because I do like it when it knows what I'm trying to type.
But still, you don't want your data to be sold.
Right, exactly. Or I don't want law enforcement is looking for me warrantedly or not, right? Whether I did something wrong or not. Let's say that I'm completely innocent, but if they're on a witch hunt, I don't want them to know everything that I typed into my phone, because they'll pick and choose what they want to know. And so I would rather have them have to get whatever information honestly, instead of having them go and say, oh, well, here's everything that he's ever typed into his phone.
Yeah.
Interesting. But yeah, I love the idea. The other thing is, though, is that all of that aside, I mean, if they get hacked or anything else, what does that tell them about me? What does that tell them about my kids? What does that tell them about some other vulnerable person in my life that I just gave up some information that they can use to take advantage of them or harm them? I mean, there are so many instances where things could really go wrong just by somebody having information that they shouldn't. So, yeah.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
All right, so let's skip ahead a little bit. Let's do TensorFlow privacy.
It's very interesting that we are still on this privacy topic. And so the TensorFlow privacy library is just a library that has been fronted with optimizers that can be used to train machine learning with differential privacy. And so it's a bit early in the day for example, for this library. I'm not aware of so many people that are using it. I haven't actually used it myself, but the GitHub repo provides many tutorials for how to use this. And so this is, again, to solve that privacy concern for users.
Mm-hmm. So, yeah, I'm just trying to figure out kind of what it does. So is it like pulling personally identifiable information out, or Is there something else that it's doing here?
So the way the package works is that when you're training machine learning models, there's what we call optimizers. And so once you train the model, TensorFlow also provides another tool for measuring whether the model that has been trained guarantees some privacy. So you can use TensorFlow privacy to train a model, and then you can use another tool to see how private, in quote, your model is. I'm not sure whether it makes a whole lot of sense.
Kind of. It might be something I just need to learn a little bit more about. But yeah, because differential privacy, I think, means something different from like privacy that I'm thinking of. And this isn't an idea that I'm necessarily familiar with. So what I may do is I may actually just reach out to them and say, hey, you want to explain this to me? Because it looks like they've got a couple of Google engineers that work on this. So I can probably just go hit them.
So it's like when it comes to differential privacy, it's not the same as federated learning, but we could think of them to be close to each other, because you remember in the example for the keyboard, we are still sharing our information, but it's not personal. We cannot identify any one individual from that data.
Okay.
So differential privacy is something similar that the data is sort of being shared publicly, but it's not. You cannot identify an individual person from all that data.
No, that makes sense. I could also see, for example, that if you build a model that works off of specific, I don't know, images or sounds or something like that. And just to give an example on this too, for example, my Echo, I think the other day I asked it what the weather was, and it said, it's going to be 80 degrees today and sunny. Have a nice day, Charles. And why did it say have a nice day, Charles? Is because it recognized my frickin' voice, right? And so there could be a level of privacy with that too, right? Where there may be some other aspect of the algorithm that would identify me, not necessarily out of the sample data, but just out of the algorithm itself. And in some cases, you want that, right? Because you want it to be personalized. Hopefully, a lot of that is localized, right? I don't know if I want Amazon's cloud to recognize my voice when I'm walking through the mall, but yeah, so some differential privacy that way would be nice, right? Where at some level in different situations, I would want privacy. And so I could see maybe them measuring that as well.
Yeah.
Interesting. But yeah, it's interesting that they're thinking about these concerns, right? In the data, in some of the other areas of TensorFlow. Yeah. What is privacy? Like, what's offered? What do we care about? What about TensorFlow Extended? What is that? TFX.
This is a platform for bringing machine learning models to production. Building a machine learning model is one thing, and getting it to actual users is another thing. And so when you build a TensorFlow model, you can use TFX to serve your model.
Okay.
So what they've done is that they've abstracted a lot of the infrastructure, but a lot of the coding and that you would need to do to bring a machine learning to production. Because what TFX does is that you'll just provide it with your model, and then it will give you an API endpoint, which you can start using right away.
Yeah, I kind of like that in the sense that it's like, hey, if you want to use my model, it has like a REST API port and stuff like that. And so if there's a standard way to just expose it out there, right, then people can use it. The other thing is, though, is that so I'm mostly a web developer, right? I spend most of my time writing Ruby on Rails apps. I don't actually do data science or machine learning at my full-time job as kind of my full-time job. And so I could see this as a handy way of saying, okay, Chuck the web developer, right? Now I'm Chuck the data science, Chuck the machine learning guy. I'm just like, hey, we're going to run this on a private network, in our cloud setup, right? And so we're just going to set this up and we're going to run this on port 1080 or something. And you just set up your Rails app so that it has makes a call into the REST API and uses the TensorFlow model to get the results that it needs. And we don't have to have any other complicated setup And if it really comes down to it, we can set up some rules in front of it using Apache or Nginx to do some kind of access control on the front end of it before it actually gets hit, if we really want to control it that way. But yeah, it gives us options outside of the, how do we cram this Python built model in TensorFlow into our Rails or Node or Java or some other system, right? And use it that way. And it gives us a different way, I guess, of making it available.
Yeah, it just makes the work of the person building the model much easier and much quicker.
Yeah.
Because you just run a few lines of code, you get an API endpoint that you can start getting predictions from your model.
Yeah. The other way I see this being helpful is you can test it easily, right? You don't have to go set up a whole bunch of infrastructure around it. You don't have to go build an app around it in order to use it. You can just put it up and then just hit the REST API and make sure you're getting the results back that you want without having to know that your intervening code isn't messing stuff up.
Yeah, actually, because running this on your local machine is quite easy. So you get your endpoint and you can start testing right away.
Yep, absolutely. So one other thing that you've got on here that looks really interesting, because, and this is something that I come back to over and over again, is that machine learning, especially with like neural networks and weights and all this stuff that we've got there, it feels like magic. And TensorBoard looks like it gives you a way of actually not necessarily explaining what's going on so much as just giving you a view into what's going on inside of your model. Do you want to explain how that works?
Sure. TensorBoard is really useful when it comes to visualizing things in your machine, when you're training your machine learning models. So, for example, you can visualize the accuracy, the loss, and see whether your model is improving or not, or whether it's overfitting. So it's a very good tool for visualization in machine learning. And the advantage is that you don't have to use it only in TensorFlow. You can also use it while you are using PyTorch. For example, you can visualize images using it. You can visualize your model weights and biases. You can even visualize the architecture of your model. Because, when you create that model, it can look like a sort of a black box, but you can use TensorBoard to see this layer goes to this layer connects to this layer. So it's a very good tool for doing that. Even you can use it to log your confusion metrics.
Oh, interesting. Yeah, I'm kind of digging it. I'm kind of wondering how, let's say you set up a TensorBoard for one of your models and you're looking at it. Yeah, how do you know if it's overfitting versus improving versus, some of the other outcomes that you're talking about, right? Is that just experience? You kind of see it change, you start going, okay, it looks like it's changing in this way, that's good, versus changing in this way, which is not as good?
Well, that's usually straightforward, because when you're training your model, you can check the performance of the model on, for example, your training data. Let's say, for example, you're getting, say, 99% accuracy on your training data, but when you try it on your testing data, you get something like maybe, say, 50% or maybe 30. Then you can tell that from the visualization, you can tell the model is overfitting. Or, for example, if you see that your loss on your training data is much higher than on the loss on your test data is much higher than the one on your training data, you can definitely tell there is something that is not okay.
Okay, so it's not just giving you weights and biases, but it's actually telling you, it says it right there. It tells you the performance of your application. And so, so you're getting the readout and you're saying, okay, it was 99% on the training data and it's 50% or 40% on the confirmation or the test data. And so, it's overfitted because it's really good at the training data and really not so good at the other data.
Yeah, you can also use the tool to share your experiment with your friend. Let's say, for example, I'm working on a model here and I want to share it with you. We can use a platform known as tensorboard.dev, where I can share this TensorBoard with you, and you can also take a look and see what's going on and also probably give me your feedback. So there's also a platform that we can use to share these
nice.
TensorBoards.
That's really cool. So which of all these tools have you found to be the most useful? Like, which are the ones that just kind of, you can't you can't live without? Like if you had to give up all but one, which one would you keep?
So, for example, TensorBoard is a very nice one because when you're building your model, you can quickly visualize it and see what's going on in your model without too much hassle. So this one is a great one. TFX is also a very other nice one because it makes just deploying your machine learning models super quick. And of course, the TensorFlow hub because sometimes you might need to solve a particular problem, but you don't have that data, and so you can just go there and grab a pre-trained model and start using it. So that's also a very nice one because it is good when the data you have is not as much, so you can use that pre-trained model and maybe just fine-tune the model to your problem.
Mm-hmm. Makes sense.
I find those ones very, very useful.
Awesome. All right. Well, we're kind of getting toward the end of our time. I know you have a hard stop coming up, as do I. So I'm going to kind of push us into the next segment of the show, which is picks.
Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming, and I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit. And you can find that at summit.mostvaluable.dev.
That's just stuff that we shout out about, stuff that we're really enjoying, that is helping us out in life, stuff like that. And I'm going to go ahead and go first, and I'm just going to shout out about some stuff. So I'm going to pick a couple of books that I've been reading and a couple of tools that I've been using lately, and then we'll kind of move along from there. I think I have a TV show that I'm going to pick too. So the first book I'm going to pick is called Who Not How. It's a more of a business book. If you're running a business, it basically encourages you to hire people to solve your problems instead of trying to figure out how to solve them yourself. And this applies much more in business, I find, than like if you're in a full-time job for technology. If they've hired you to solve a problem, you probably have to figure out how to solve the problem. But if you're running your own business or if you're a team lead, a lot of times the right answer is to find somebody who can solve the problem. So anyway, I really have been enjoying that, just as far as building the podcast network and stuff like that, finding the right people to solve the problems. It's awesome. The other pick that I have for books is I've been listening to a book called Fanatical Prospecting, which is a sales book. Yeah, I'm on a business book kick right now, and I'm really digging that as well. And so, yeah, I'm going to shout out about that book as well. If you're into sales or in a position where you need to do sales, this book has really come together and been terrific. And then TV show. So my wife is kind of I would say she's kind of a World War II history person. She really likes that history. I wouldn't say she's like a fanatic because she doesn't watch like every documentary about it, but she does get into it. But it's funny because some things I think she'd really get into and then she doesn't. So I don't know. She kind of picks and chooses. But one show, she's kind of watching it for the second time with her dad. And I kind of watch it off and on with him. Watched it through with her once and really enjoyed it. It's called Hunting Hitler, and it's a History Channel series. And basically the premise of the show is that a bunch of documents from the FBI were declassified, where they essentially revealed that after Adolf Hitler was believed to have been found dead in the Führer bunker in Berlin after the Russians came in and took over Berlin in World War II, they found a bunch of evidence that the FBI was still looking for him and that he may not have died in the Führer bunker. And so they explore all the evidence that he was dead, and all the evidence that he might not have died, and all the evidence that he might have gotten away and how he might have done it. And it's really, really fascinating. And then I think there's ample evidence that he may have actually survived. I don't know that it's definitive, right? You can definitely blow holes in none of this proves, right, that he survived. But it definitely demonstrates that it was possible and that he had a place to go, that he may have escaped to South America. But anyway, really, really interesting. And it's really kind of this interesting look into history, right? And to these German survivors who escaped to South America and some of the people that they found. I think there was a movie that came out not too long ago, too, where these Israeli assassins went and assassinated, I can't remember who it was, but it was somebody really high up in the Nazi command structure that had escaped to Brazil or Argentina or something, right? And they had to sneak in and kidnap him or kill him. No, they kidnapped him so they could put him on trial, and they kidnapped him without getting caught, right? Because their kidnapping was illegal in the country they were in. But anyway, so it's all that kind of cloak and dagger stuff, really fascinating stuff. And so I'm going to pick that if you're into that kind of history. Derrick, do you have some things you want to pick or shout out about, people ought to know about, or just things that you're enjoying or liking?
You saw that in the beginning, I work in data science and marketing, quite a combo there. So I also read some marketing books. So like right now I'm reading Purple Cow by Seth Godin. And this is classic. Marketing. Yeah, those two. Purple Cow and this is marketing.
Good stuff. Yeah, Seth Godin's a smart dude.
Yeah.
Very cool. If people want to find you online, where do they connect with you?
LinkedIn.
All right. Well, we'll make sure that we get a link to your... What was that?
Mostly Twitter and LinkedIn, but mostly LinkedIn.
Okay. If you want to put those links in the chat, we'll make sure they wind up in the show notes. And yeah, we'll put a link to your article as well. And then, thanks for coming. This was a lot of fun to just kind of talk through some of these tools. Now I have all this stuff to go play with this weekend.
Thank you for having me. Maybe I can come back again sometime.
Yeah, absolutely.
Okay.
All right. Well, we'll wrap it up here, folks. And until next time, Max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.